You're watching What's Up with Giancarlo. How's everybody doing? Today we're going to get into 7.1. This is writing and solving one-step inequalities. All right? Inequalities are the greater than, which you guys would say is an open alligator mouth, less than a closed out, well, not facing you, but less than. And then there's greater than or equal to, which there's a line under it. So that can mean 9 is greater than or equal to 9. It includes it. And then we have less than or equal to, which is also 9 is less than or equal to 9. All right. So it means it's 9 is less than or equal to 9 and everything above it. And then greater than or equal to is 9 is greater than or equal to 9, but this 9 can be more. So it's like I have 9 here and I have 9 here, but then it's going up. So like 10, 11, and then this is 9, and then we have 9 here, and then we go to 10, we go to 11, and so on and so forth. All right? Just starting off. Investigating inequalities, you know that when you perform any of the 4 basic operations on both sides of an equation, the resulting equation is still true. What that means is whatever you do to one side, you must do to the other, okay? What effect does performing these operations on both sides of an inequality have? So, inequality, add to both sides, new inequality. So I'm going to add 3 to both sides. So, plus 3, plus 3. This side will become 5. This side will become 0. Yes, it's still true. 5 is still greater than or equal to 0. Add to both sides. So it's really just minus 1 and then minus 1. So I'm going to have negative 2 is less than or equal to 5. Is that true? Yes, that's true. Because, class, all of these were going to be true. I'm just going to reveal this right now. As long as you do it to both sides, this statement does not change. The numbers might, but the statement does not change because it remains equal. Whatever I do to this side, I do to this side, and it remains equal. So I'm going to subtract 8 from both sides. This is negative 16, and that is still greater than negative 18. All right? Let's go. Complete the table. Divide both sides by. Woo. All right, class. So this is a little bit trickier. Okay? So I'm going to show you right now. Dividing both sides by 8, okay. Write this down. If you multiply or divide by a negative number, the inequality, must flip. All right? So let's look at this. 4 divided by 4 is 1. So we get 1 on this side, and 8 divided by 4 is 2. So new inequality is right there. And then is that true? Yes, still true. We do the same thing here. 12 divided by 3 is 4. Negative 15 divided by 3. The 3 is positive, so we're dividing by a positive 3, so it's negative 5. It stays negative, but that doesn't make the inequality switch. So there's a new inequality. 4 is greater than or equal to negative 5. Is that true? Yeah, that's true. All right. So now we have this. We have negative 16 divided by negative 4. All right. So negative, it's going to turn positive, and 16 divided by 4 is 4. 12 divided by a negative 4, there's only one negative, so it will be negative. Your answer will be negative, and 12 divided by 4 is 3, so it'll be a negative 3. Is 4 less than or equal to negative 3? No, that's false. So to make that true, we have to flip this inequality. What do you notice? Okay, same thing here. Negative 5. So I'm dividing 15 by negative 5. My answer is going to be negative 3 because there's only one negative. And then 5 divided by negative 5 is going to be negative 1. Negative 3 is not greater than negative 1, so it is false. So you'd flip it again, and then boom. What do you notice when you divide both sides of an inequality by the same negative number? The inequality is no longer true. Class, I guess I got here a little early, but please write this down, and please make sure you know this. We will be going over it in a short amount of time. If you multiply or divide by a negative number, the inequality must flip. If these inequalities flipped, they would be true. Just remember that. That is very, very important in this lesson. Solving inequalities involving addition and subtraction. You can use properties of inequality to solve inequalities involving addition and subtraction with rational numbers. Addition and subtraction properties of inequality. So class, what these are saying is, as long as I add or subtract to both sides, the inequality remains true. It stays true. As long as you add or subtract to both sides, whatever you do to one side, you do it to the other, the inequality stays true when you're adding and subtracting. Solve each inequality, graph and check the solution. Now class, another note that I would like you to take right now. We've got greater than and less than equals open dot. Greater than or equal to and less than or equal to equals closed dot. All right? Please write that down. If you do not write that down, you might forget it, and that is very, very bad. You will get a lot of questions wrong if you do not pay attention to this, okay? You must pay attention. So, I will let you know where that goes. I've got x plus 5 is less than negative 12. I need this is just like a regular equation. I need my variable all alone. So I'm going to do the opposite. I'm going to subtract 5 from both sides. So these cancel out. I'm left with x on the left side, and then negative 12 plus minus 5. You would really add them both, so it's negative 12 and negative 5 equals negative 17. So I have x is less than negative 17. So class, my point that I'm going to graph on the number line is negative 17. So I put a big circle, an open circle, since it's less than, and we look at our little key right here. We put an open circle on 17. And then since x is less than negative 17, we go to the left. All right? X is less than. It's your variable. So now x can be anything that's shaded on the left side. All right. So moving on. 8 is less than or equal to y minus 3. We have to add 3 to both sides. This cancels out. 8 plus 3 is 11. We get 11 is less than or equal to y. So if we go back and look at our key, less than or equal to is closed dot. So we go to 11. 11, close dot, y is greater than it. Y is greater than or equal to 11. So it's going to go to the right. All right, pause real quick and then work this out on your own. Three, two, one. Y minus 5 is greater than or equal to negative 7. We're going to get, this is your final inequality. This is the graph, and this is how you work it out. You're going to add 5 to each side, and adding a positive 5 to a negative 7 gives you negative 2. All right. Pause it. 3, 2, 1. That's your inequality. They rewrote it so x was on the other side. All right. So just working it out, it would be x, no. It would be 9 is greater than x if you just work it out that way. And then we go to 9, we put our circle, and then since x is less than it, we're going to the left. Our open circle, class. And that's how you work it out. All right. So now we get into a little bit tougher part. Solving inequalities involving multiplication and division. You can use properties of inequality to solve inequalities involving multiplication and division with rational numbers. So class, you can multiply or divide both sides of an inequality by the same positive number and the inequality will remain true. If you are multiplying or dividing by a positive number, nothing changes. But if you are multiplying or dividing by a negative number for an inequality, you have to reverse the inequality symbol. You have to flip it. So if I have a greater than sign, and I'm dividing or multiplying by a negative number, at the end of my problem, it's going to end up being a less than sign. Okay? Do not forget to do that. I might be screaming in your ear right now, but do not forget to do that. So, solve each inequality. I have a division right here. My y is dividing by 3, so I must multiply both sides by 3. So when I do that, the 3's make 1, so I just have 1y, which is y, and then, or y over 1, and then I have y is greater than or equal to 3 times 5 is 15. So it's greater than or equal to, so you guys should really do it every single time, or just write it once on your paper. I'm switching, so I'm switching pages, so I'm just going to rewrite it. So close circle on 15 because that's my point, and then the variable is greater, so I'm going to the right. Then if you check, we'll go 18. 18, we'll plug it in. 18 as y over divided by 3 is 6, and that is greater than or equal to 5, so it is true. All right, moving on. All right, so we've got negative 4x is greater than 52. Okay, so we've got multiplication, so we're going to divide. We are going to divide by a negative number, so you need to remember to reverse or flip, whichever one you want to call it, the inequality sign. Okay, So we divide by -4, and they even do it as soon as they're dividing. They're just like, hey, let's just get it done right now. So it goes from greater than to less than when they're dividing. So they get 52 divided by -4, and that is x is less than -13. So remember, equals closed dot. All right. So since it's less than, we have our open dot on 13. That's an open dot, class. And then we move it to the left. We move it to the left. Okay? Because x is less than -13, it's going to be to the left of -13. Okay, class? You need to pay attention. It's the variable that we're marking with these arrows. All right? Going to give you guys, let you pause it right here so you guys can work it on your own. 3, 2, 1. All right. So class, this is how you work it out. It's -10y is less than 60. We're going to divide by a negative. So we divide by -10. They should have switched it right here, but they end up switching in the answer. So it's 60 divided by -10 is -6. So y is greater than -6. So we put our open circle, and then we go to the right since y is greater than it. We're going to the right since y is greater than it. All right. So we've got another your turn. Pause it now. Work on it yourself. 3, 2, 1. So they gave us another one. So class, I'm just going to show you it because they really like having the variable on the left side. That'll help with the which way to go with the arrow, but I'll just show you it the actual way. So I've got -t/6, so I'm going to multiply by -6, both sides. All right, that looks like -6, but no, we'll put parentheses around them both. All right, so -6 times 7. Well, first off, let's flip that around. That's -42. And then those make 1, so it's t/1, which is just t. So this is the same as this, except so you can write it this way, or you can write it this way, but you have to make sure you copy it down right. All right? Either way works. All right? But remember, if it's equal to, it's a closed dot, we go to -42, and then t is greater than it, so we're going to the right. We are going to the right. All right? Moving on. Solving a real world problem. Although elevations below sea level are represented by negative numbers, we often use absolute values to describe these elevations. For example, -50 feet relative to sea level might be described as 50 feet below sea level. Class, even though the number is negative, we use a +50 and then we explain that it's below sea level, so that means it's negative. You know what I'm saying? So it's like you're going 50 feet underground. Ground is 0. If you're going 50 feet underground, that's -50. That's -50. Okay? So a marine submersible descends more than 40 feet below sea level. Descends means they're going down. Okay? Descends is going down. As it descends from sea level, the change in elevation is -5 feet per second. For how many seconds does it descend? So I've got -5. I'm just going x. They use t. Is less than -40. Okay? So this is multiplication. I have to divide by -5, -5. I get x. We have to flip it is greater than positive 8. Negative divided by negative gives me a positive. So x is greater than 8. The submersible descends for more than 8 seconds. Okay? It has to be, so it's going to go farther than 40 feet. So it's going to be less than 40 feet, obviously. So if it's going to be negative 5 feet per second, it's going to take more than 8 seconds to get past the negative 40 feet. To get lower than 40 feet below sea level is going to take more than 8 seconds. Pause it right now. 3, 2, 1. Every month, $35 is withdrawn from Tony's savings account to pay for his gym membership. He has enough savings to withdraw no more than $315. For how many months can Tony pay for his gym membership? M is less than or equal to 9. Tony can pay for no more than 9 months of his gym membership. All right. So it's 35x is less than or equal to 315. He cannot spend more than 315 savings to withdraw no more than. So he can withdraw all 315, but he can't go over that. So it has to be less than or equal to. So at this point, I'm going to divide both sides by 35. And then x is going to be less than or equal to 9. So Tony can pay for no more than 9 months. He can pay for 9 months, but he can't go over that. So it's either 9 months or less. All right. So that wraps up lesson 7.1. I hope everybody has a nice day. Stay safe. And remember, if you're watching this, you're a part of the class.